the last part of our basic AOI logic is the inverter. What the inverter does is it takes the input signal and swaps it. So if we come in high, logic high, with a 1, our output will be 0. If we come in with a logic low, a 0, our output will be a 1, logic high. So we're taking that signal and flipping it. So in this case, we express that as A bar equals Z, or not A equals Z. So what's that really mean? I don't have two inputs like before, okay? So we don't need to even remotely see what B is going to do. We're just going to have A. And since we're in binary, we only have two choices. We have a 0 or a 1. So when we look at this, if I send A into the inverter and it is 0, the output I'm going to get is a 1. If I send a 1 into the inverter, I'm going to get out a 0. And that's essentially our truth table for an inverter. How does an inverter look in our ladder logic? Well, very similar to our AND, only we only have one input here. We still have our output. We have Q 4.0, and we have our A right here, and we have I 0.0. Now, the only difference is we have not A, so we represent that as with a line through it. This means normally closed. Okay? So if we use not A here, that means as long as I have the machine up and running, this output's always going to be on until I actually hit or control the contactor here and open it up. So it's always going to be closed until you press a button or it receives a command that says to open. When this opens, then it will turn off. So this guy's always going to be running. So that's what our inverter looks like. Alright, well, if we compare an inverter on the chip up here, you can actually have 6 inverters on the chip because there's only an input and an output. So you're only using one in, one out, so you can have more gates on a chip with an inverter.